Wait, what? A trip tomorrow? That's crazy. Where are we going? New York? No way. That's awesome. I'm definitely in. We're flying? Alright, I need to book my ticket fast. I'll do it right now. I need to book a flight from London to New York for tomorrow, preferably in the morning. Economy. Bob. Yes, go ahead. Finally the tickets are booked. But how does the chatbot works?
Let's answer Bob's query by exploring how a chatbot works. A chatbot processes user input through multiple steps to generate a meaningful response. Here's a simplified NLP workflow. Step 1. User input. Step 2. Pre-processing the text. Step 3. Intent recognition. Step 4. Entity extraction. Step 5. Context management. Step 6. Response generation. Step 7. Post-processing and output. Now, let's dive deeper into each step. Now, let's talk about how chatbots receive user input. When a user wants to interact with a chatbot, they can do so in two ways: text input or voice input. In scenario 1, the user directly types their query, and the chatbot reads this text. For example, I want to book a flight to New York tomorrow. Then immediately begins natural language processing to understand the request and generate a response. In scenario 2, the user provides a voice input, which requires an additional step. First, the user speaks their request. Again, I want to book a flight to New York tomorrow. This spoken input is then processed by a speech-to-text, a STT engine, such as Google Speech API. The STT engine converts the voice into text, making it readable by the chatbot. Once converted, the chatbot processes it, just like text input using NLP. This process ensures that users can communicate with chatbots in a natural and flexible manner, whether by typing or speaking. In the next section, we'll explore how the chatbot processes this input using NLP techniques. Once the chatbot receives the user's input, the next crucial step is pre-processing the text. The first step in this process is tokenization. Tokenization involves breaking down the input text into individual words or sentences. In our example, I want to book a flight to New York tomorrow is split into tokens like I want to book a flight to New York tomorrow. This step helps the chatbot analyze the input word by word. Next, we apply stop word removal. Stop words are common words like I, to, and a that do not contribute much meaning to the overall intent. By removing these words, we refine the input into a more meaningful representation. After stop word removal, our sentence becomes want, book, flight, New York, tomorrow. This pre-processing helps simplify the text, making it easier for the chatbot to extract intent and key entities. In the next slide, we will look at how the chatbot further processes this cleaned input using NLP techniques. First, we apply lemmatization, which reduces words to their base or dictionary form. For example, like booking becomes book, helping the chatbot better understand the intent. In our case, book a flight represents refined action. Next, we perform POS, part of speech tagging, which assigns grammatical categories to words. This step helps the chatbot understand sentence structure. Here, want and book are identified as verbs, flight as a noun, tomorrow as an adverb, time, and New York as a proper noun, place. With these techniques, the chatbot can accurately interpret the user's intent and extract meaningful data for further processing. Next, we will explore how intent detection and entity recognition work together to generate an appropriate response. In this step, we focus on intent recognition, which is like AI reading your mind. Once the AI processes the text, it tries to identify the intent behind the user's message. For example, if the user says, book a flight, the AI detects that the intent is flight booking. Now, how does it do this? The AI can use machine learning models like support vector machines, SVM, or deep learning, or it can rely on rule-based systems where predefined keywords trigger specific responses. To truly understand how AI works, you need to think like AI. If a user only says, book a flight without providing details, the AI would ask follow-up questions like where and when to gather more information. This step ensures that the AI understands what the user wants before moving forward with a relevant response. Now that the AI has identified the intent, the next step is entity extraction. This is where AI detects and pulls out key details from the user's input. For example, if the user says, book a flight to New York for tomorrow, AI extracts the destination as New York and the date as tomorrow. How does AI do this? It uses natural language processing and NLP techniques such as named entity recognition, NER, to identify entities like locations, dates, and names. Now, let's think like AI. What if the user says next Friday instead of tomorrow? AI must interpret that correctly as a specific date. This requires contextual understanding, and AI often relies on pre-trained language models or date parsing libraries to resolve such terms accurately. Now, let's talk about an essential feature of modern chatbots: context management. Context management allows a chatbot to store conversation history, connect past user inputs, and eliminate unnecessary repetition. For example, let's consider this conversation. The user first says, I want to book a flight to New York tomorrow. The chatbot then asks, what time would you like to depart? The user simply replies, at 7 p.m. Here's where context management plays a crucial role. Even though the user didn't mention New York or tomorrow again, the chatbot remembers these details from the previous input. It retains key information like the destination, date, and time to process the booking correctly without asking redundant questions. This ability to track and recall context is what makes modern chatbots more intelligent and user-friendly. Without context management, users would have to repeat details in every interaction, making the experience frustrating. This feature enhances the chatbot's ability to provide seamless and human-like conversations. Now, let's move on to one of the most critical aspects of a chatbot: response generation. Chatbots generate responses using different approaches, and they primarily fall into three categories: rule-based, retrieval-based, and generative AI. First, we have rule-based chatbots. These use predefined replies for specific inputs. They follow a structured pattern, meaning they can only respond to what they have been explicitly programmed for. While simple and efficient, they lack flexibility in handling complex or unexpected queries. Next, we have retrieval-based chatbots. These work by selecting the best response from a predefined database. They use techniques like keyword matching or machine learning to retrieve the most relevant response based on the user's query. While they provide more variety than rule-based systems, they still rely on an existing set of responses and do not generate new ones. Finally, we have generative AI-based chatbots. These leverage deep learning models like GPT to create dynamic responses. Unlike rule-based or retrieval-based approaches, generative models do not rely on predefined responses. Instead, they generate unique replies based on learned patterns, making conversations more natural and human-like. This is the most advanced form of response generation, as it allows chatbots to handle a wide range of queries, adapt to different contexts, and provide personalized responses. Each of these response generation methods has its use cases, and modern chatbots often combine these techniques to provide the best user experience. With advancements in AI, we are seeing a shift towards more generative models, making chatbots smarter and more conversational. Once a chatbot generates a response, it goes through several post-processing steps to ensure accuracy and clarity before reaching the user. First, we have grammar correction and fluency check. This step refines the chatbot's response by fixing grammatical errors and improving sentence structure. For example, instead of saying, "Your flight booking confirmed for New York tomorrow," it is corrected to, "Your flight to New York is confirmed for tomorrow." Next is formatting and data conversion. Here, the chatbot processes dates, numbers, and other details into a user-friendly format. For instance, if a user says tomorrow, the chatbot translates it into an exact date like February 15th, 2025, ensuring clarity in communication. Finally, we have text-to-speech, TTS, conversion. Once the text is refined, it can be sent to a TTS engine, which converts it into speech. This allows users to hear responses instead of reading them, making the chatbot more accessible and interactive. Together, these steps ensure the chatbot delivers clear, precise, and user-friendly responses across different formats. To improve over time, chatbots rely on continuous learning. This involves three key techniques. First, supervised learning, where logs are reviewed to fix errors. If a chatbot fails to understand a phrase like cheapest flight, developers analyze logs and train the model to recognize it in the future. Next is reinforcement learning, where the chatbot learns from interactions. For example, if users frequently select low-cost flights, the chatbot adapts by prioritizing budget-friendly options. Finally, chatbot analytics tracks user behavior and common requests. It helps understand user preferences like favorite airlines or frequent flight rescheduling, enhancing response accuracy over time. These methods ensure chatbots become smarter, more accurate, and better suited to user needs.
Whoa! That's how chatbots work. They take inputs, process requests, and respond in real time. This is amazing. You know what? I'm going to design my own chatbot.